Okay, this is the Unit 1, Lesson 14 video, and we are in Chapter 6, Section 5 of the textbook, and we will be talking about operations with radical expressions in this lesson. The content standard that we're going to look at is use the structure of an expression to identify ways to rewrite it, and our mathematical practice is making sense of problems and persevering in solving them, which means there's going to be a few steps to this process, and perseverance, the only time they're going to ask you to persevere is when they think you might give up because the problems might be kind of difficult. So figure out what's going on and then persevere, stick with it, and you'll get through it. So in the past, we've simplified expressions with nth roots. We did that back in Lesson 13. In this lesson, we are going to simplify radical expressions, and we're going to just do the basic math operations with radical expressions. We're going to add and subtract, multiply, and divide. So our new vocabulary, this time, we're going to be talking about something called rationalizing the denominator. We're going to talk about radical expressions, and we're going to talk about what a conjugate is. And we've already looked at conjugates back when we did complex numbers, so hopefully you'll have a little bit of a concept of what that might be already coming into the lesson. So our key concept in this lesson is the product property of radicals, which says that if you have the nth root of the product of two things, a times b, that's the nth root of a times the nth root of b. Basically, each thing gets its own root symbol, and you can break it up that way. So root 2 times root 8 is actually root 16, which we know is 4. And root 3 times root 9, or cube root of root 3, cube root of 3 times cube root of 9 is the same as the cube root of 3 times 9, which is 27, which we know the cube root of 27 is 3, because 3 times 3 times 3 is 27. So our first example, we're going to simplify expressions with the product property, and we need to simplify the square root of a to the 4th, b to the 9th. And this is actually pretty simple. All we have to do is figure out, we're going to give each thing its own square root, and I'm sure they're going to write that later when I show the stuff, but I'm just going to go straight to the answer right now. So I'm going to do the square root of 25, which I know is 5. I'm going to do the square root of a to the 4th, and here's a little hint that the square root of something, so x right now, is the exact same as x to the 1/2 power. And the cube root would be the 1/3 power, and the 4th root would be the 1/4 power, and so on and so on. So when I'm doing a to the 4th and taking the square root, I'm really just doing a to the 4th to the 1/2 power. Let me write that. Which is multiplying exponents. And 4 times a half, or half of 4 is 2, so I know this is a squared. And then I'm doing b to the 9th to the 1/2 power. And that would be 9 times a half, or half of 9, which would be b to the 9 over 2 power. So that's what I think the answer is. Let's see what they say in their work. So notice that they said their final answer a little bit differently. What they did is they took b to the 9th and they called it b to the 8th. This right here, 4 times 2, that would be b to the 8th times another b. And they took the square root of b to the 8th, which is just b to the 4th, because you're taking half of 8, which is 4. And then they're taking this extra b power and just writing it as the square root of b. So this is actually a better form of what I said in my previous thing. Okay, let's try the same concept, but we're doing a cube root this time. So here's what I'm thinking. I'm going to do the cube root of 125, and I know from looking at the exponent table, or just because I've memorized this, that the cube root of 125 is 5. And then I'm going to do the cube root of 30, m to the 30th. That's 1/3, or taking 30 and dividing by 3, and that's going to give me m to the 10th power. And then for p, I'm thinking this is 20 divided by 3, and 20 does not evenly divide by 3. So I'm going to go to the next lowest value below 20, the next lowest power that would divide evenly by 3, and that would be 18. So I know that p to the 20th is the same as p to the 18th power times p to the 2nd power. And 18, if I divide that by 3, that's going to give me 6. And then I'm left over with this. So if I have all of this stuff under a cube root, I'm going to be left over with the cube root of p squared. So this is my final answer, and let me make sure that they get the same thing. And it looks like they got the same thing. 5m to the 10th, p to the 6th, times the cube root of p squared. Same answer. All right, here's one for you guys to check your progress on. You got the square root of 16, x to the 4th, y to the 11th. Pause the video as long as you need. When you have your answer, come on back and go to the next slide. Okay, our answer this time is letter A. Okay, for part B, check your progress. This time we have a 4th root. We haven't seen a 4th root yet, but we have the 4th root of 625 b to the 28th k to the 23rd power. Pause the video as long as you need. When you're ready and you have your answer, come on back and go to the next slide. Your answer this time is C. And you see this has absolute value in it. We haven't talked about why the absolute value is there in this video. I'm pretty sure we did in the last video, so hopefully you remember this. But if you're not sure about why the absolute value is there, go ahead and ask me about that in class. All right, the quotient property of radicals is the same concept. If you have a quotient, the numerator and the denominator, each piece can get its own root. So for example 2, part A, we're going to simplify expressions with the quotient property this time. We need to simplify the square root of y to the 8th over x to the 7th. So I'm just going to look and see what they do this time, rather than say everything myself. We're going to give each thing, the numerator and the denominator, its own square root. We're going to rewrite 8 as 4 to the 2nd power, because 4 times 2 gives us 8. And then the square root and the square can cancel, so we'll be left with y to the 4th in the numerator. And the 7th, if we want to take half of 7, we can't take that evenly, so we're going to go down to 6. 3 times 2 gives us the 6th power. We'll be able to take that out evenly, and we'll be left over with a square root of x. Notice right here we're left over with a square root of x. So you have y to the 4th over x cubed times the square root of x. And here's where rationalizing the denominator comes in. Basically, the concept for rationalizing a denominator means that you are not allowed to stop if you have a square root in your denominator. So you need to get all of the roots, all the cube roots, all the 4th roots, whatever kind of roots you have, get them out of the denominator and only keep them in the numerator. So the way you do that is, if you have a square root, you're going to multiply by the square root of that thing, x, in this case, square root of x over the square root of x. If you multiply by this, you are really just multiplying by the number 1. Notice that something over itself is always just the number 1. When we multiply the square root of x times the square root of x, that would give us the square root of x squared. And you know those cancel each other out. That's why there's just an x left over, and x to the 3rd is going to be multiplied by this x. X to the 3rd times x, that's how we get this x to the 4th down here. And then the numerator is y to the 4th times root x, and that's where this comes from. Check it out. This is exactly what they said over here. This right here is your final answer. All right, part B, this time we have a cube root of 2 over 9x. So again, just like before, what we're going to do first is give each thing its own cube root. The numerator gets a cube root, the denominator gets a cube root. The tricky thing this time is we need to take this 9x and think about how we could turn it into a perfect cube, because we have a cube root and we want this to be a perfect cube. So what I know already is that 9, that's 3 squared. But I want to know, what is 3 cubed? And how do I get from 3 squared over to 3 cubed? Simply, the way we do that is we're going to multiply by another 3. So on my denominator, to rationalize it, I need to multiply by another 3. And I'm also starting with x, and I want to end up with x cubed. So how do I get from x over to x cubed? Well, I'm going to multiply by x to the second power. And if I do that, x times x squared, I'm going to get x cubed. Then I'll have a perfect cube on both of these factors. So I need to multiply by 3x squared, and I need to be multiplied by the cube root of that on the numerator and the denominator. That's how I'm going to rationalize my denominator in this case. So when we do that, the numerator simplifies to cube root of 6x squared. The denominator simplifies to cube root of 27x cubed. The cube root of 27 is 3. The cube root of x cubed is just x. Here's what we have. Pretty sure that's our final answer. Let's go ahead into the next slide and make sure that's the final answer. Yep, there's your final answer, the cube root of 6x squared over 3x. Okay, here's one for you to check your progress on. Pause the video as long as you need to solve this, and then when you have your answer, come on back and advance to the next slide. And our answer to part A is letter C. We're going to do a part B also. We've got a cube root for this one. Pause the video as long as you need. When you have your answer, come on back and go to the next slide. Okay, our answer to part B is C again. All right, we're going to pick up with simplifying radical expressions in the next video.